All right, here we go. We are getting started. Chapter 10 starts today. As you notice when you picked up your beautiful brand new Chapter 10 notes packet, it is a little bit thicker than Chapter 8. And yes, I skipped the number 9. In an effort to prepare you for your air test, we have rearranged the chapters, okay? So here we go. Today is kind of a throwback to middle school. If you notice, our learning target says, I can find the area of parallelograms and triangles. You did those before, right? Oh, yeah. So they should be probably quick and easy. At the end, I will give you your check for understanding. Homework is 15 questions. The maximum amount of questions in this chapter is Math Excel, I believe, is 16. Okay? Please notice you have a quiz on Friday. Okay? Your quiz on Friday covers the first 3 sections, but the first 2 sections should be review from middle school. Okay? So it shouldn't be that terribly painful. Here we go. A parallelogram with the same base and height as a rectangle has the same area as the rectangle. Okay? How do you find the area of a rectangle, you ask? Well, I hope you remember that to find the area of a rectangle, all you got to do is base times height. Okay. So as I said by my definition, okay, if a parallelogram has the same base and the same height measurement as the rectangle, the area is going to be the same. So essentially what I want you to visualize in your head, you're taking this rectangle, and the only thing I did was started to slant the sides a little bit. And that is what created my parallelogram. That is why they have the exact same formula, base times height. Make sense? All right, so a few things I still need you to know. I need you to know what an altitude is, and I also need you to understand how to figure out which piece is the base, okay? So a base of a parallelogram can actually be any one of its sides, okay? It can be any one of them. Now the corresponding height is going to be that altitude piece. If it's base times height, you have to figure out which altitude it is that I'm using. So let's remember what an altitude is. An altitude is that segment that is perpendicular to the side opposite of it. Okay? The height and the altitude, those go hand in hand. Okay? The length of the height is also the length of the altitude. Alright? I want you to notice something. We like this one here because it's pretty obvious. Here is the base. Here is the height, right? Base times height, pretty straightforward. If I want to look at this guy here and use this base, because this base is not a horizontal or a vertical line, it's a little bit trickier as to figuring out what the length of the height is. So what you have to remember is the height is always going to be that base that is perpendicular to its opposite side. So technically, I could have drawn that altitude here. Remember definition of altitude, it makes that right angle. Okay? All right, ready? 2 examples, here we go. What are the areas of each of these parallelograms? So let's look at question A. We got to do base times height, right? Which base would you like to use? Which base? 5. Okay, so we're going to use 5 as our base. And what are we going to use as our height? The 4. All right, so we got 5 times 4. That gets us an area of, I love it, 20 square inches. She knows that Mrs. Kosak loves to make sure you conclude those units of measure. Okay, inches squared. All right, let's look at B. Area equals base times height. This one's a little trickier. What are we going to use as our height? The 3.5 piece, okay? Because we're seeing this right angle measure. Okay, so we're going to use 3.5 as our height. 3.5 is the height for what base? 2. The 2. Because notice this line is perpendicular to this line. And the height is the altitude, okay? So we're using 2 as our base. All right, all we got to do is 2 times 3.5. What do I get? 7 centimeters squared. Very good. Questions on that? All right, I want to point something out. Why did I include this piece of information? Why did I include this piece of information? Throw you off, okay? That is considered extraneous information. In an effort to confuse you, I'm going to include pieces just to make sure you actually know what you're looking at. Did you already do your got it? Look, I put a kitty. Did you like the kitty? You didn't do your got it yet? Where are your units squared? Oh no. I don't know who taught this to you at Hastings or Jones, but they are crying a little bit. Are you ready to check your answer? All right, let's see what the kitty says. The kitty says you should have an answer of 108 meters squared. Do you agree with the kitty?
Yes.
Okay. I'm attempting to start to appreciate kitties because I'm not a huge fan of them personally. We'll see how that goes. All right, here is this parallelogram. This parallelogram is named ABCD. I want to know the length of DE. I want to know this value here to the nearest 10. What is DE? It's an altitude. Okay, DE is the altitude for which base?
9.4.
The 9.4 base. Okay, so we know that DE is the altitude for the 9.4 base, and we know that base times height gets us our area, correct? I wonder if we can find the area of this figure with other information that's been provided. Can we find the area?
Yeah.
Okay. Which two pieces go together?
9 and 13.
The 9 and the 13. We have a base length of 13, which is perpendicular to the length of 9. So let's use that to find the area. So we're going to do 13 times 9. What does that get for our area? 117. Did Heidi do her math right? We start to not trust Heidi? Do I need to do units?
Inches squared.
Inches squared. Okay, so now I know that the area of this parallelogram is 117 inches squared. What can I do with that?
9.4.
I'm going to divide that by 9.4 ultimately. You're very correct. So we're going to take 117 and we're going to set this equal to the other pieces that go together. The other base was 9.4. And I know when I multiply a base by its height, that gets me the area. So like CJ just said, I'm going to divide both sides by 9.4. So what is 117 divided by 9.4?
12.4.
12.4? We like CJ. Do we trust CJ?
Inches squared.
Ooh.
Oh, wait, no, inches.
What is a unit?
Inches.
Just inches. All right, let me give you a thought on this type of problem. This is the problem that was most commonly missed on the quiz for Friday last year. It was so commonly missed that I got so upset that I put it on the Chapter 10 test again, just to make sure they heeded my warning. Just a thought. Questions on how we do this problem? Why do you think that people got confused about this problem last year?
I would have thought it was still 1 inches squared.
Okay, maybe it was the inches squared that threw them off. I don't think that was what did them in, though. Why were people struggling with this particular problem last year?
Didn't quite plug in the 117.
They don't know how the 117 plays a role. They didn't even know how to find. They didn't even know that's what they were. Bleh. They didn't know that's where they needed to start. They didn't understand that it doesn't matter which base and which height you use to find area, so long as you're using the corresponding base and the height, because then you can use it to find the other piece. Okay. This whole problem was just a world of difficulty. All right, your turn. Yours is in Word format. The kitty has returned. Okay, some of you have already done this. See, I told you we were reviewing middle school today. some of you are drawing pictures for your parallelogram. That's fine. You do not need to do that on this particular problem. But if that helps you, that is okay with me. Okay, you ready to check your answer on this one? Did I go too fast? All right. The kitty says the answer should be 7.5. Do you like the kitty? Should I continue using a kitty? I don't want to use a kitty. It's cute though. All right, questions on this one?
Why do you like cats?
I'm a dog person.
Same.
Because I was trying to learn to like cats. My husband wants a cat.
What's wrong with cats?
Cats can be.
I just scratch
They scratch you exactly. All right.
them.
But see, then that's very cruel. That's so cruel. All right.
Oops, both my cats are declawed.
I have never heard you guys get this chatty during a lesson. New seats. Ooh, maybe we should go back to the old ones. All right, how do I find the area of a triangle? Because I'm hoping you remember this. I hope we've already talked about this, but the area of a triangle is half the product of its base and its corresponding height. 1/2 base times height. The reason why it is 1/2 base times height is because essentially what I could do is draw a triangle that matches that triangle, and then what shape do I have? A parallelogram. And what was the area formula for a parallelogram? Base times height. And I take away one of those triangles, and that is why it is 1/2 base times height. Okay? Questions on that concept? Do you remember learning that? All right, well then let's practice it with my real world problem here. You'll want to make a triangular sail like the one at the right. How many square feet of material do you need? So some things that I'm looking for when solving a problem such as this. I'm looking for the altitude, which means if I'm looking for the altitude, I'm looking for a segment that has a right angle, because the altitude is going to be my height. Okay? All right, so area equals 1/2 base times height. What am I going to use for my base here? 160. Very good. What am I going to use for my height? 146. All right, we need 1/2 of 160 times 146. What do we get? It's a big number, right? 11,680. Guess what? I agree with you. Good. 11,680. What? Inches squared. Interesting. That's not right. Oh, it wants feet. Uh-oh. It wants feet. How do I go from square inches to square feet? I am not dividing this by 12. That is not how you convert to feet squared. I do divide it by 144. So this is the rule. 1 inch equals 1/12 of a foot, right? I should have written that better. Let's do 12 inches equals 1 foot. 12 inches equals 1 foot, right? When you think about a square, okay? If the square is 12 inches by 12 inches, okay, that's what? The area of this is going to be 12 times 12, which is 144. This is the same thing as 1 foot here, 1 foot here. So that is why we need to use a conversion that 144 inches squared is equal to 1 foot squared. Does that make sense? No? Yes? No? Maybe? What could I have done to shortcut all that and not have to worry about dividing by 144? Because I could have done something else. I could have started with the beginning of the problem and converted my inches to feet. Because in that situation, we would have divided this by, and we would have divided this guy by, so notice you would have divided by 12 twice. 12 times 12 is 144, okay? So 11,680, divide that by 144, what do we get? 1,728. We agree? Did you do that right? I'm not checking. 11,680 divided by 144. We agree with that answer? No? Oh, see? I'm concerned. What's 11,680 divided by 144? I'm hearing different answers. What?
81.
81? 0.1?
Mm-hmm.
Okay. Now are we a little happy with that one? I knew she was going to slip up today. I had a feeling. She's allowed to slip up. All right. Let me, before I move on, do you understand this conversion? You understand you don't just divide by 12? All right. Here's your got it. Beware of my got it. Don't be stooped by my got it. Check.
I was at first.
You were at first?
Be careful.
Me too.
Ah, the kids were last year as well. I stumped them last year. And last year I did it as an ed puzzle, and I didn't even warn them. Didn't go so hot. What is the warning that all your friends are referring to? On this got it. The inches and the feet. Notice on my triangle I gave you different units of measure. What are you using as your base in this triangle? The 5? Okay, so you use the base of 5. Then what's the height going to be? Oh, the 12 inches. Because that's actually labeled as 1 foot. All right, ready to check your answer? All right. That seems like a lot of work. Did you get an answer of 30 inches squared? Yes? I personally would just leave it in terms of inches. I don't want to convert it to feet squared. All right, how you feeling? Okay, last problem. Told you this was a toughie here. What is the area of the figure at the right? Oh my God, I've never taught you anything like that before. What do you do? Heidi?
You find the area of the square and then you triangle and add them.
Oh, okay. So you find 2 different areas and you add them together. I can handle that. All right. So she sees this as a square. How did Heidi know that this was a square? Got congruent markings and what else? All right. How do you find the area of a square? Base times height. Okay. So area of a square. Base is what?
6.
Height is what?
6.
So the area of my square is
36.
36
Inches
inches squared. Very good. All right. Then Heidi said, okay, now, Mrs. Kosak, find the area of the triangle. So we know triangle area formula is 1/2 base times height. What am I using as my base in this problem? Okay, what am I using as my height?
8.
Okay. Half of 6 is 3. 3 times 8 is 24 inches squared. And then Heidi said, take those 2 areas, Mrs. Kosak, and add them together. What do we add them together to get?
60.
60 square inches. Very good. All right, questions on that? Okay, read your got it very carefully. Your got it says, suppose that the base lengths of the square and the triangle in the figure above are double to 12 inches, but the height of each polygon remains the same. How is the area of the figure affected? So maybe it'd be helpful to find the actual area, right? Did you already do that? Okay, give me 1 more minute. I'll show your answer. If you're feeling good about this and you want to move on to your check for understanding for the day, that's your last task. Okay? All right. Those of you who are ready I got an answer of 96 for my area. Do you agree with 96? No? Yes? Was the base of your shape a square any longer? What did it become? A rectangle. Okay. Questions on this problem? Alright. You got a check for understanding that is a whopping 5 questions long. Oh my goodness. You may utilize your notes, which does have your formulas, but please be warned. Please, please, please be warned. You are not given formulas on any quiz or test in this chapter. So you do need to know those formulas on your own. Okay? Alright, y'all good? Alright. You may move on to Schoology to take the check for understanding. And then I will look at those results. When you're done with those, you can do Math Excel.